Good evening to all. Let's discuss about the working principle of gas turbine. So, gas turbine is a machine used for generation of power for industrial application. However, when gas turbine is used for generating the thrust for aeroplane, jet fighter plane or rocket engine, etc. also. In case of industrial application, the exhaust gas of the turbine is still hot and so it is sent to boiler for recovery of heat, and so gas becomes cool and then goes out to atmosphere through chimney or a stack. In case of aeroplane or fighter plane or rocket engine, exhaust of turbine is used as a thrust which is exhausted to atmosphere directly. Thrust force in opposite direction of gas exiting, that is erection force, and is generated to aeroplane or jet fighter planes, which is used for cruising these equipments. Now you can see a sketch of gas turbine. It has shown axial gas turbine. It has multiple stages. Typically, it is used as an impulse and reaction gas turbine, and it is designed for 50%. You can say reaction turbine, which is best for efficiency. And IGV, you can see this is IGV, which is used for control the flow as per power requirement. And since inlet temperature of gas mixture after combustion becomes very hot in the tune of 1200 degrees Celsius to 1400 degrees Celsius, and so blades are manufactured with a special material, and also internal cooling of the blade is normally done with high pressure of air taken from the compressor itself. Cooling is channeled inside the blades and comes out from the cooling holes of the blades. Now, gas turbine has mainly three sections. One is compression sections. Normally, axial compressors are used where the pressure of air or gas has to be increased by the compression, which is driven by gas turbine itself. Then another section is a gas combustion chamber where the high pressure gas mixes with fuel and burns. So after combustion, the enthalpy of burnt gas is increased, which is used to feed to the turbine. Then another is a turbine itself, turbine section, where the actual pressure drop occurs and energy is extracted from the hot gas and delivered to or generated for power generation. A gas turbine works on the principle of Brayton cycle, and Brayton cycle can be typically two types. One is closed Brayton cycle and open Brayton cycle. In case of closed Brayton cycle, you can see the process gas number one is compressed in compressor, which is process 1 and 2, and compressor is considered as isentropic compression process. So suitable gas process is compressed in process 1 and 2. Then process 2 and 3, you can see here the constant pressure heat addition to the process. So hot fluid is transferring heat to this process fluid in this process. And the process 3 and 4 is a real expansion, isentropic expansion in the turbine, which is a isentropic process. So actual heat is extracted from the hot gas by the turbine and power is generated. Then process 4 and 1 is constant pressure heat rejection. You can see there is another heat exchange. So hot gas which is coming from the turbine is heat is taken by another fluid, and that is how it is called constant pressure heat rejection process. You can see in the PV diagram also the process 1 and 2 is compression, process 2 is heat addition, then process 3 and 4 is expansion, and process 4 1 and is a heat rejection process. So this is a closed Brayton cycle. The same thing had been also shown on the this power generation process. You can see the turbine is connected to generator and process also same PV diagram. In case of open Brayton cycle, you can see that air is compressed from process 1 and 2 in the compression process, which is considered as a constant uh, entropy process or isentropic process. Process 2 and 3 where the actual combustion takes place, and so air and fuel mixes, and after combustion, so the enthalpy of gas mixture becomes high, which is fed to turbine. So process 3 and 4 is isentropic expansion process where actual expansion of the gas occurs and power is generated. And from process 4, it is exhausted to atmosphere in case of jet engine, whereas in case of industrial turbine, it is fed to boilers where heat is again further taken by the boiler for steam generation. Same thing is shown process 1 and 2 in PV diagram is a compression process of air. 2 and 3 is a heat radiation, that is in combustion chamber. 3 and 4 is expansion in the turbine, and 4 and 1 is shown as a dotted line because this is open process. In fact, after 4 it goes to atmosphere. Same thing shown in a open Brayton cycle for the power generation process. So turbine is connected to generators, and same process shown on PV diagram here. So I hope you have enjoyed this. Thank you. Thank you for watching.